Alright, today we're going to be doing the heat of fusion of ice lab. You're going to need some items very, again, commonly found around the house, maybe some polystyrene cups, some hot water from the tap. Really, it works best with really hot water. Some ice cubes, and be able to make some measurements utilizing, again, some your household measuring cups. That should be what you need. And then it's pretty much do some calculations. So here we go. All right, I'm going to continue to use the LabQuest for my items. I have a polystyrene cup, measuring cup for my hot water, and then some ice cubes as well. I have my data table all set up so that I'm able to record items as I need them to have in here. And so as you can see, it's not too lengthy of a lab. If anything, it does require more calculations that are a little bit more involved that we covered yesterday in notes. As you can see, the piece of ice is melting, lowering my temperature. When it's all gone, I wait for the temperature to be all stabilized to its lowest value. Then I do it all over again. How do you get the mass of the water after if you don't know what it was? Well, if you look, I have 175 milliliters, which means I have about 175 grams of water. Using what you know to help you figure it out. You should be able to do the calculations, finding the change in temperature of the hot water, utilizing the temperature of the hot water and the final temperature when they're combined, finding the heat lost by the water by utilizing the change in temperature, the mass of the hot water, the specific heat of water. You'll also be asked to find the change in temperature for the ice, starting from a negative 10.3 degrees Celsius to a 40.5 degrees Celsius. You'll be able to find the heat gained by the ice, which should be the mass of the ice times the specific heat and your change in temperature. Now, the heat lost plus the heat gained should equate out to somewhat zero, but it might not. So what you're going to do is find whatever that is, utilize that to find the heat of fusion of ice in calories per gram, find the heat of fusion of ice in kilojoules per mole, and then that average, which means all of these values. And then find, utilizing the information that we were given in notes yesterday, that would give us the percent error. Therefore, you should have everything you need to solve the problem if you haven't already done it with your data. So this one's a little bit more intensive with the amount of calculations. Now, if you were utilizing numbers or an Excel spreadsheet type program, you could actually make it do a lot of the work for you. I'm not going to go into doing how that is done here, but if you wanted to do that, you definitely could explore that option. And then, because once you do it in one cell and kind of get it to work with one way, you should be able to copy and paste that for everything else. And then copy and paste that whole file or get a good picture of it, of your data, and put that into your lab book. That would be what you would ideally be able to look at. You can play and manipulate some things out. You could even graph it, some of the items too if you needed to, but you might not need to. And so therefore you would be able to do a lot of these things. So a lot of these things could, the labs that we've done over this year would have been nice to be able to put into graphs and but our tables, and then actually have it do some of the calculations for you, especially in some of these labs that are very calculation based. You would just need to put in what the calculation was that you used in your calculations, and then just your data table would already automatically do that, and it would allow for a lot of manipulation in some of those types of things. As we continue forward, this would be, I believe, the last lab for Unit 6 for thermochemistry as we prepare now for the next adventure.